geometric property question. This entire question is 12 marks. So geometric properties and trigo is always very, very important. This question is 12 marks. Yeah. So Cambridge is really very strange. If you notice the way they phrase the question, right? They are very particular to tell you that the points lie exactly on the circle. So I find it very strange that last year, that particular question, they didn't mention anything specifically. It's such a weird thing. A, B, C are points on the smaller circle, center O, and C, D, E, F are points on the larger circle, center P. A, O, C, P, E, B, C, D, and D, P, F are all straight lines. So they are very clear. A, O, C, P, E is a straight line. They tell you very, very clearly. And they are straight lines that pass through both centers of the circle. Angle CPF is 96 degrees. Find angle DEP. Where is DEP? DEP is here. Right? How to find this angle? What do we look for? I told you all before many times, anytime you see triangles inscribed within a circle that passes through the center, label your equal. What kind of triangle is CPF? It is an isosceles triangle. Right? So once you know it's an isosceles triangle, very straightforward. They never say state the reasons, but you should know you need to state the reasons. So angle DPE is equal to angle CPF equals to 96 degrees because vertically opposite angles. Right? And therefore angle DEP is the base angle of your isosceles triangle, isn't it? 180 minus 96 divided by 2. Again, write your reason. Base angles of isosceles triangle DEP. Angle question always never write. Unit 1, so please write. Show that triangle ABC is similar to triangle FCD. This is not relevant to your N-level students. N-level students don't need to know how to prove that they are similar. You only need to know how to apply. You must know how to apply, but you don't need to know how to prove. But it's a very quick question. I will just go and do it. How to show that they are similar? Most of the time, similarity is used what? AA similarity, right? But if you look at triangle ABC and you look at triangle FCD, the question here to ask yourself is it AA similarity? Can you prove AA similarity? Can or cannot? You can. You can prove AA similarity. How? The first obvious similar angle is always going to be your 90 degree, right? Angle ABC is equal to angle DCF equals to 90 degree. Zachary, what's the reason? So right angle in semicircle. Right? Now, the other similar angle to prove is a little bit more abstract. It's a little bit more abstract. Which angle do I want to prove? I will know that this angle is equal to this angle, agree? Because vertically opposite angle, right? So angle ACB is equal to angle DCP. Because vertically opposite angles, right? An angle DCP, on the other hand, is also similar to which is equal to which angle? DCP will be equal to this angle over here, isn't it? It will be equal to CDP because base angles of isosceles triangle DCP. Therefore, angle ACB is equal to angle CDP by association. Okay, this is called mathematical induction. If A is equal to B and B is equal to C, then by induction, A must be equal to C. And so now I prove that ACB is equal to CDP, right? And therefore, triangle ABC is similar to triangle FCD because of AA similarity. Free 3 marks. And notice the number of lines they give you is exact one. All right, N-level students don't need to know how to prove, but must know how to apply. So the geometric properties here, you still need to know, just that they won't have a question that asks you to show that the triangles are similar. Now that DE is given as 7.21, where is DE? Where in the world is DE? 7.21. Then they tell you that DF is 9.7. Where is DF? DF is this whole thing, 9.7. And then BD is 9.1. Where is BD? BD is 9.1. Calculate the length AB. Then you notice, seems very easy, then you realize they tell you it's 4 marks. Where is AB? AB is this. Obviously, they ask you to prove similarity for a reason, right? So AB must correspond to which length? AB must correspond to FC, right? So even though in N level, you don't need to prove similarity, you must still know how to do part C. Because I tell you they are similar, you must know what to do. So AB will correspond to FC, right? AB, FC. Where is FC? FC is this length. Common mistake that students will make is students will tell me, oh, so easy. FC is just 7.21. Is that correct? Why not? Say no, my question to you is, why not? Is FC 7.21 or is FC not 7.21? It's a very interesting question. It is. Why? it is that this is indeed 7.21. For 4 marks, I would go and prove that they are the same. A lot of students will assume they are the same. I suspect that Cambridge for 4 marks will penalize you some marks because they will ask you, how do you know that they are the same? But how come they are the same? You can use cosine rule to go and figure it out, right? If this is R, this is R, this is R, this is R, by cosine rule, if I give you this value, then this value must be the same value because the angles are the same and the radiuses are the same, right? Make sense? So they will actually be equal. So it would indeed be equal. Actually, now that I think about it, I don't think they need you to show that it is equal. Yeah, I don't think they need you to show that it's equal because if I apply Pythagoras, do I need to show that it's equal? I don't think so. But you need to know that they are actually going to be equal. Okay, you can use cosine rule, or you can prove to me that actually those two triangles are congruent by RHS. Right? This triangle and this triangle are congruent because hypotenuse is the same, right? Because hypotenuse is the diameter. And you have a common length and you have a right angle. So by RHS, they will be equal. They will be congruent triangles. And if they are congruent, then obviously the lengths will be the same. So yes, you are supposed to know that this is also going to be 7.21. So many students will assume that it's 7.21 without understanding why and be able to solve the question. I don't think Cambridge will penalize them. Now, but that doesn't explain how do I find AB? I am given BD is 9.1. How do I use BD to go and find AB? So this is where there are triangles, right? So within your triangles, actually, what can you use? You can use your sine rule, right? You can use your cosine rule, right? We already found the angle DE, P is 42 degrees. So if this is 42 degrees, you will know that this is also 42 degrees. This will also be 42 degrees. Oops. This will also be 42 degrees. So you can use your sine rule or you can use your cosine rule. Either one up to you. Right? I know that by similar triangles, AB over CF is the ratio that I want, right? I just need one corresponding length to go and find, right? And I already proved that this angle is equal to this angle, isn't it? So by similar triangles, right, this angle will also be, what would this angle over here be? This corresponds to this, right? So we know that this is 42 degrees. Right? Why I want to know that that is 42 degrees? I'm given that the entirety of B. I'm given the entirety of BD. But if I'm given the entirety of BD, in theory, I can go and find this, isn't it? I can find that, right? By sine rule or by cosine rule, actually either one I will be able to find. In fact, I don't even need, because I got right angle triangle, actually what can I just use? I don't even need sine rule or cosine rule. Remember, don't forget, this is a right angle triangle. Angle CDE is 90 degrees because right angle in semicircle. So sometimes you all look at questions like that, right? You all see geometric properties. It doesn't come naturally to you that within geometric properties of circles, I can apply sine rule or cosine rule or even Tuakaso. But that's what the question wants you to do. I can just apply Torcaso to find CD, right? Because I got the 7.21, I have the 42 degree that I already found. I know that this is right angle because right angle in semicircle. So I have opposite. Sorry, I have adjacent. I want to find opposite. I use tangent. So tangent 42 degrees is equal to so actually the fact that CF is 7.21, you don't necessarily need to use also, but you can use it if you want to use similarity to solve. But I can actually find the value of AB directly without similarity. So this will give me, I can go ahead and find CD. So this is opposite, which is CD, over adjacent, which is DE. So tangent 42 is opposite, which is CD, over adjacent 7.21. And therefore CD is equal to 7.21 tangent 42 degrees. You can leave your answer as a 5SF value. So 7.21 tangent 42 is 6.4919 in 5SF. Or you can leave it as an exact value, 7.21 tangent 42, up to you. And that is the reason why they gave you the entire length of BD. They gave you BD so that you can just directly... Oh, I just realized they gave me DF also. I never see the DF. Oops. So actually DF is equal to CE. So actually there are many ways to solve the question. They give you a lot more information than you actually need. Okay, but by trigo, I will find CD is this. And because I'm given BD, right? Therefore, I can find this length over here, right? I can find BC. And therefore, BC is equal to 9.10 minus CD, which is 6.4919, which will give me 2.6081. So now that I found BC, you should know that angle ABC, just now we already proved that ABC is 90 degrees, right? So we don't need to prove it again. Then now we can apply trigonometric ratio because we know that angle BAC is equal to 42 degrees, but we haven't shown that. So angle BAC is equal to angle BAC is equal to angle CFD, right? Because corresponding angles of similar triangles. Which thing you got different answer? Your CD is different. You use CD to find Pythagoras. You use Pythagoras to find CD. So you use square root of 9.7 square minus 7.21 square. You got 6.48, is it? Okay, what? What's wrong? 6.49 and 6.488 it's not considered significantly different. It is acceptable. It is within the acceptable range. Okay. If I round over both to 3SF, what do I get? 6.49, right? So to the examiner, it's the same value. Okay, if you use Pythagoras, you got 6.488. You use tangent, you got 6.491. To the examiner, you round to 3SF, they are the same value. Don't need to worry about that. And this is also equal to angle DP because this is angles in same segment. And therefore, this is equal to 42 degrees. a long convoluted way of saying that the angle is 42 degrees. But for 4 marks, I will put everything there. I don't think Cambridge will deduct any mark if you just tell me that BAC is 42 degrees. But for 4 marks, why take the risk? Just go and write it. Okay? So we first show that this angle is equal to this angle. And then why is this angle 42? Because this angle is equal to this angle. Angles in the same segment. Okay? Once I have the 42 degrees, I got BC. I want to find AB. That's the opposite and my adjacent, right? So I can go and use tangent again. So tangent 42 degrees is equal to opposite, which is what I want, right? Is BC. Wait, it's not. Opposite is not what I want. It's AB that I want. Tangent 42 is equal to opposite, which is BC, which is 2.6081 over adjacent, which is AB, which is what I want. And therefore, AB is equal to 2.6081 over tangent 42, which will give me 2.8966 in 5SF, which is equal to 2.90 in 3SF. Do you get 2.90? If you use your value of AB, you should, your 3SF value should still end up becoming the same. So even though your value of your BC would differ slightly because your value of CD is slightly different, when you eventually round it off to 3SF, you will find that it will give you back the same value one. Okay? Like that is 4 marks. It's actually not a very difficult 4 marks. It's just that you must remember that in geometric properties of circles, I can still apply trigo. So the thing that sometimes students look at this kind of question, they forget that trigo exists because you are so used to finding angles, right? Then you forget that in angles, you also have trigo. If you're wondering why they give you so little space for a 4-mark question, if I remember correctly, in the actual exam paper, there was more space. The publisher took away some of the space. The document is loading so quickly. In the original question, they give you a lot more space. Let's move on. Part 2, calculate the length of the minor arc AB for 3 marks. This entire question is, where's the minor arc AB? Minor arc AB is here. Minor arc AB is this. To find the minor arc AB, what do you need? Don't forget, to find minor arc is always with reference to the angle at the center. So you need to go and draw in this extra line. You already previously proved that this is 42, right? So you will know that this angle over here will also be 42 because you will form an isosceles triangle this way. So again, I don't know why this is a 3-mark question, but okay. So what angle do I want to find? I want to find angle AOB, right? So I will know that angle OAB is equal to angle OBA. angle OAB is equal to angle OBA equals to 42 degrees because base angles of isosceles triangle AOB. And therefore, angle AOB is equal to 180 minus 2 times 42 degrees to give me 96 degrees. Angle sum of triangle AOB. And therefore, minor arc AB. Arc AB can also be represented using the notation. You draw a curve above AB to indicate that it's an arc, but normally we don't use this notation. It's not really taught to you. Okay, but if you ever see it, there was a school paper that I've seen before that uses this notation, then the student got very confused what the notation means. This means arc AB. Okay, but anyway, minor arc AB is given by, y'all be careful. What have I not found? Have I found the radius? Yes, I have found, no, I have not found the radius, right? We did not find the radius if you realize. So we still need to go and find the radius before we can go and find. That's why it's a 3-mark question, I see. How to find the radius? You found the arc AB, you find the length of AB just now already. What's the length of AB? AB is 2.8966. That's what we found just now. Okay. If you know that this is 2.8966, how do I go on to find the radius? Sine rule law. Nothing better to do, right? I mean, yeah, you should just use sine rule. Okay, so I need to find the radius AO. I will go ahead and use sine rule. So by sine rule, I want to find the length, right? So 2.8966 over 96 degrees over sine 96 degrees is equal to AO over sine 42 degrees. And therefore AO is equal to one 1.9489 in 5SF. So that's your radius. And therefore, your minor arc AB is equal to, this is not radian, so don't tell me R theta. This is your theta over 360, which is 42, not 42, 96 over 360 times pi times 2 times radius, which is 1.9489. Please remember the formula for circumference is 2 pi r in this form. Sometimes we forget to multiply by 2. It's a final answer, so you can just directly leave in 3SF. We don't need it anymore. There are a few different possible ways to find the radius. You can also use the similarity that you showed just now to go and find the radius of the big circle and then go and find the radius of the small circle by similarity and things like that. Many different ways to find the missing lengths that you want. Up to you which one you can visualize in your exam.